In this try it exercise, we're moving away from the real number system to something that I had referenced earlier on in the course. We're moving on to the complex number system. What happens when we're taking the square root of a negative number? Well, remember, the imaginary number I is such that I squared equals -1. Now, what that means is that I equals the square root of -1. It occurs in conjugate pairs, just like regular solutions do when we're dealing with quadratics. Typically, we could put plus or minus the square root of -1 there, but that's not necessary. It'll all come out in the wash when we solve, when we take the square root of both sides. So the process is essentially the same. The difference is that when we get to taking the square root of a negative number, we factor out the negative, and that becomes I. So initially, the process is the same. We have c squared plus 12 equals 0. We want to isolate the variable term being squared, so in this case, c squared. We do that by subtracting 12 from both sides. That gives us c squared on the left and -12 on the right. So we take the square root of both sides, square root of c squared. This is what I meant about it coming out in the wash. We put a plus or minus when we take the square root, just like we always would. So the left side ends up being c equals plus or minus the square root of -12. Now remember, that's the same thing as plus or minus the square root of -1 times 12. And there's where that I comes into place. Plus or minus square root of -1 is I. So c equals plus or minus the square root of 12 times I. Because this equals plus or minus square root of -1 times the square root of 12, just like we can always do with using the properties of radicals. Now this will simplify because 12 has a factor of 4, which is a perfect square. If we factor out that 4, that becomes 4 times 3. Square root of 4 is 2. So plus or minus 2 times the square root of 3i. Check our solution by substituting back into the original equation. So let's check. Let's go with our negative first, as we always do. So we want to know, does -2 times the square root of 3i squared plus 12 equals 0. So we'll substitute -2 times the square root of 3i squared plus 12. We want to know, does that equal 0? So there are a lot of things going on inside this small value, digits wise at least. -2 squared, we have to square that first. That becomes 4. -2 squared is 4. Square root of 3 squared is 3. And then we have I squared. Plus 12, does that equal 0? 4 times 3 is 12. I squared is -1. So this becomes -12 plus 12, which does indeed equal 0. And again, with with a negative being squared like this, if we simply change it, we could substitute for +2 times the square root of 3i. But if we simply change this to a plus, the second and second and subsequent steps are the same as if it's negative because it's being squared. So our solution checks: c squared plus 12 equals 0 when c equals +2 times the square root of 3i.